All right, so the first assignment, there's confusion about, well, on your part, but confusion on my part as to, the holiday on Monday. So the assignment is going to be due Friday next week, assignment 1. So I updated the due date on the website here. So that'll be due Friday, the 29th by 5 p.m. Okay. So far we've covered, number 1, the stuff about truth tables, and number 3 here. I want to do a couple more examples for number 3, and then get into the final bit about translations. Is there anyone that has any questions still about truth tables? About number 1? Anyone have still any questions on number 1 about the truth tables? All right. So number 3. So we want to verify that these are tautologies, via a sequence of known tautological equivalences. So that was covered last time. So where is it? So we had that whole table of known or named tautological equivalences. So implication tautology, contrapositive, double implication, associativity, commutativity, double negation, distribution, De Morgan's laws, complementation, identity, annihilation, idempotent. Remember, 0 means false, 1 means true. So we want to we use those to prove that this was a tautology right here last time, that A naught or A implies B naught or B is logically equivalent to 1. In other words, it's true always. So we showed that was a tautology by using those tautological equivalences in a chain like this, starting with the left-hand side and working our way all the way to the right-hand side like that. Okay, in a chain of equivalences. Right, where under each equivalence we give the name of the equivalence used. Implication, De Morgan and double negation, associative, distributive, complement, so on and so forth. Okay, so let's do another example like that. A couple more examples like that. So some more examples. Of tautological equivalences built from named tautologies. You can always show that a propositional logic statement is a tautology simply by using a truth table. But these are important as well. These because they're a new type of algebra that has importance in various areas, and this type of algebra is called Boolean algebra. Okay. Anyway, so to show that A implies B naught is logically equivalent to A naught and B. This is an easy one. It's just a quick one, but it's one to remember. If you have a negation, or sorry, an implication, if A then B. If A then B, and you want to negate it, the negation of it is the conjunction A naught and B. In other words, A implies B is false when the hypothesis is, A and B naught. When the hypothesis is true and the conclusion is false. So that's something I've been kind of saying for a while now. But anyway, the negation of an implication is that. Let's formalize it. Okay. So we start with the left-hand side. All right, and we want to use these named tautologies. So we'll start off with the implication tautology. So what was the implication tautology? All right, that A implies B is logically equivalent to A naught or B. Okay, so A implies B, logically equivalent to A naught or B. All right, so I can replace the A implies B with A naught or B. And now with De Morgan, right, De Morgan's law says what? De Morgan's law says P or Q naught is logically equivalent to P naught and Q naught. P or Q naught logically equivalent to P naught and Q naught. So this is logically equivalent to A naught naught and B naught. And then using double negation, you could do this all in one step. A naught naught is just A. Okay, so the negation of an implication, A implies B, is logically equivalent to A and B naught. All right, so let's do one a little more involved. So is true or is it tautology? So let's show that A or B naught, or A implies C naught, or B implies C naught, or C is logically equivalent to 1. In other words, this thing here is always true no matter what A, B, and C are. Right, so this is a tautology if and only if the truth value here and here are always the same. And the truth value here is always 1, so we're essentially showing that this is a tautology. Anyway, so we start with this and we simplify down to 1. So A or B naught, or A implies C naught, or B implies C naught, or C. So, well, we already did the negation of A implies C and B implies C, right? The negation of A implies B is A and B naught, right? So we already did that sequence up here. So let's just quote that sequence. So implication De Morgan plus double negation gives us what? So this is still A or B naught, but then this becomes what? what does the A implies C not become?
A naught or B?
This one here.
Oh, I'm sorry, A naught or C?
A and C naught.
Oh.
Oh, I see what you're saying. You were doing it. Let's just go from start to finish here. Yeah, you were going in that first step. Yeah, I see what you're saying. So let's just do all three steps at once since we already covered that. And then the B implies C not becomes what? B implies C not becomes
B and C naught.
right. Are these parentheses that I've written here all necessary?
No.
Hmm.
Okay. Yes.
Yes, because negation, or sorry, conjunction and disjunction, neither one has precedence over the other. All right, a couple different ways one can proceed here. What's one way one might do it? There's only one really, well, there's two, but there's one, whatchamacallit, tautology, name tautology, one can apply here. I mean, you can apply De Morgan to this one, but let's not bother with that. Other than that, there's only one tautology. Sorry?
Distribution.
Distribution. There's a couple different ways to apply it. A couple different ways to apply it. Okay, I'm going to apply it like this. So first of all, now remember what we were saying, like disjunction. You can take a disjunction of however many terms you want, and you don't really need, you don't need to put parentheses there. I mean, technically you can only do two at a time, but you can define it so you can do three or more at a time. But if you're going to use distribution, distribution only applies, for disjunction, distributing over conjunction, or the other way around. You can only do it with two at a time, so you better block off two that you want to use. And the two I'm going to block off are these two right here. So we'll just call that associativity. So this is going to be A or B, not. Or, and I'm gonna group these two together, A and C, or sorry, A and C naught, or B and C naught, or C. Okay, just putting that parentheses there so that I can apply distribution. Now you might have been thinking, I want to go like this. I want to go like this and distribute this C, this disjunction over that conjunction. That's fine. You can do it that way. That'll be all right. I just feel like doing it this way. All right, so I'm using distribution in reverse. So we want to factor out the C naught. And I get what? Right, I want to factor out the C naught. And what do I get? All right, so here we have like P and Q or R and Q. And distribution says that that's logically equivalent to P or R and Q. Okay, so I'm going sort of in the opposite direction. I'm factoring out the Q. In this case, the Q is C naught. So how's it going to look here?
A or B.
A or B, parentheses,
And C.
and C naught. Yeah. Okay. Now, distribution again. I'm going to distribute this or this disjunction over this conjunction. And that's going to give me what? So I still have this term here, A or B, not. Or, now what? Distribute this C or, P and Q. C or,
Would it be
go ahead.
A or B or C
Mm-hmm.
and B not or C?
C not or C, right? Right, C or C not, and C or A or B or C. Now you got to be really careful about. I'm going to put that all in one. You've got to be careful about not mixing the ands and the ors together. Okay, this is a conjunction right here, right? So this is C or A or B. So A or B or C, I can make that one disjunction of three things. And C or C not. So that's got to be distinct from this and here. So these disjunctions need to be kept separate from this conjunction. Okay, C or C not. C not or C. What's that? This one's called complement.
Could that just be 1?
That's one, right? So this becomes A or B not, or A or B or C. And 1. All right. So, and 1. All right. A or B or C and 1. So P and 1. Right, P conjunction, something that's true, was just logically equivalent to P. That was called the identity. Right, so and 1, that's like a multiplicative identity or something like that. Right, it's like multiplying by 1. So this just becomes A or B not, or an A or B or C, and then that other extra parentheses can go away because that conjunction is gone. So now I'm going to use associativity. So this is all right. This is all just conjunction. A or B, or sorry, that's A or B not, or A or B. I'll put it like that, or C. A or B not, or A or B. That's like P or P not. What was that? We used that one already, actually, right up here. Right here. C or not, C not or C was 1. Similarly, like this is, think of this as just one letter, right? P sorry, P not or P is what?
That's 1 again.
That's 1 again. Okay, by the way, notice that, when we're using those tautologies, when we're saying P or P not is logically equivalent to 1, right? I mean, P can be any propositional logic statement that you want, like this. right? This is A or B, or A or B not. Logically equivalent to 1 again, right? This is, we're thinking of P as A or B, and again, P is A or B. So this is P, this is P not. All right, so this is 1 or C. That was complement again. And then 1 or C is logically equivalent to what?
C.
1 and C
1.
is 1. That one was called what? It's got the cool
Annihilation.
annihilation. So let's take a look at those, and that's what we wanted to show. Okay, we wanted to show that this, from the very beginning, this propositional logic statement is logically equivalent to 1, and that's what we've got. Okay, let's take a look at those name tautologies again. Oops, not on this page. Just real quick. So down here at the bottom, right? So there's complementation. Think like about like multiplication and addition for a moment. Okay. So this is like A plus the negative of A is 0. And A times the reciprocal of A is 1. Kind of like akin to that. Right? Like A times 1 over A is 1, and A plus the negative of A is 0. Kind of like that sort of thing. That's the analog. And then there's identity, right? Like A times 1 is A. And A plus 0 is A. But then there's these annihilation rules. So this is like A times 0 is 0. And then there actually isn't a 1 for addition. It's different Boolean algebra. But it's kind of analogous to what goes on in the arithmetic of real numbers. So there's these identity ones. So 1 is a conjunctive identity, but it's a disjunctive annihilator. 0 is a disjunctive identity, but a conjunctive annihilator. All right, so back here we had 1 or C. So by annihilation, that's C. Or annihilation, it's 1. All right. So you got to get started on the homework, guys. Do not leave it till next week on Wednesday. All right, please. It's not gonna happen for you if you do that. You got to start today if you haven't already. Get done, problems 1 and 3, and a good start on the others, and then you can ask questions on Monday, and then you finish up towards the end of the week. All right, so get started on an ASAP if you have not already. With proof type math, although we're not quite there yet, it's different than calculus and differential equations, which you may have taken already. Where it's not it's not a topic of calculation; it's a topic of explanation. So this is not what you've done throughout all of your school mathematics career. They kind of try to hint at it these days in element. I mean, they do a much better job than they did when I was in school. Trust me. The math. I don't know why everyone's so down on the new math curriculum. It's actually very good. And that's coming from a professional mathematician with a nationally funded research agenda. They do try to do a little bit of that in elementary school, though it just doesn't really sink in. I don't think it does. But it needs some extra time. All right, guys. So don't wait till the last minute to start on stuff. All right. So let's get back to chapter 1, and next time come prepared with questions if you're still a little confused about it. So we were getting into translations of English language statements from propositional, or from English language statements to propositional logic. So, so example. Let's write a propositional logic statement with the same truth value as the English language statement. So, for example, let H, K, and A be these propositions. The horse is fresh, the knight will win, the armor is strong. Or the knight wins, or however you need to conjugate these things. So A, if the horse is fresh, then the knight will win. If the horse is fresh, then the knight will win. So that's a standard way of stating an implication. H implies K. And it's a good one in that it keeps things in the right order. So this is H, arrow pointing to K. So if H, then K. All right, this one. The knight will win only if the horse is fresh. The knight will win only if the horse is fresh. So this is again implication. But is it K implies H or H implies K? Which one is it? So let's compare. All right, is it K implies H or H implies K? Page, because we're going to use this drawing a couple times. All right, so remember, implication is a containment relationship. Right? This one represents K implies H, and this one represents H implies K. So now if you look at something in the gap here, this is an instance of K naught and H. The knight lost, and his horse is fresh. This is an instance of H naught and K. The horse is tired and the knight won. The horse is tired and the knight won. Which one of these is wrong? Which one, this one or this one, contradicts that? This says the knight will win only if the horse is fresh. The knight wins only if the horse is fresh. So can he win with a tired horse?
No.
The tired horse. No. The knight cannot win with a tired horse because this is saying the knight will win only if the horse is fresh. This one says the knight lost even though he had a fresh horse. The knight lost even though he had a fresh horse. It says the knight will win only if he has a fresh horse. It doesn't say anything about, fresh horse is going to allow the knight to win. Just that it's necessary for that horse to be fresh for the knight to win. Okay, so this one is wrong. So it's K implies H. Is there an easier way to see this? No. You have to look at the two statements and you have to decide which one is wrong or conclusively say which one is right unless it's immediately obvious to you. Okay, the knight will win only if the horse is fresh. Let's change this statement just slightly. Let's change this. Just erase the word only. The knight will win if the horse is fresh. And let's change this to part C. Sorry guys, it's so loud here. The knight will win if the horse is fresh. The knight will win if the horse is fresh. Which one? Again, it's an implication. It's either K implies H or H implies K. Okay, so, well, which one is wrong? This, look in the gap. Look in the gap and see which one contradicts that statement. All right, here, The knight lost, but he had a fresh horse. The knight will win if he's got a fresh horse. Here, the knight lost, and he's got a fresh horse. Here, the horse is tired, and the knight won anyway. Which one contradicts this?
K implies H.
Right. Oops, this one is the contradiction. The knight lost, and he has a fresh horse. This says the knight will win if he has a fresh horse. So this is the opposite implication of that one. Just changing that one word. So this one is H implies K. We know that it's H implies K because we know that is wrong. That contradicts this statement. So hence the term if and only if. The knight will win if and only if the horse is fresh. So this is H, if and only, logically equivalent to K. So if and only if, the if is this implication, the only if is the opposite implication. The converse, as it's often called. So if the term H if K, right? So this is K if H. K if H is the same as if H then K. I know it's twisted, you know, to you know, this logic of implications, the way implications get twisted all over the place in the English language. But that's, you know, it's not my fault. That's the English language's fault. So who can you blame for that? Who should you direct your wrath at besides me? For the scourge that is modern English. Y'all know that, right? Who's to blame? You guys don't know where modern English came from? Okay, well,
Old English?
what's that?
Old English?
No, modern. The language whose fault is it for the twisted, the way it twists around implications? Well, I mean, modern English itself is right. I mean, it was codified by starting with King Henry VIII, right? Anyway, so you can direct your wrath at him. So here's another way in which things get twisted. So a fresh horse is necessary for the knight to win. A fresh horse is necessary for the knight to win. So let's grab this figure here again. So the words necessary and sufficient again give you an implication statement. Which one is it? Is it K implies H or H implies K? Again, look in the gap here between the two sets. This is an instance of the knight losing with a fresh horse. This is an instance of the knight winning with a tired horse. A fresh horse is necessary for the knight to win. Here the knight won with a tired horse. Here, the knight lost, but his horse was fresh. Which one contradicts the fact or the idea that a fresh horse is necessary for the knight to win?
H implies K.
Well, this one, the knight won with a tired horse. Right? The knight won with a tired horse. So yeah, H implies K is the wrong one. Right? A fresh horse is necessary. So here the horse is tired, and the knight won anyway. So that contradicts this. So this is K implies H. So a fresh horse is necessary for the knight to win. So one way you might want to think about this is that the necessary condition is the conclusion. The necessary condition is the conclusion. It's the bigger set in the containment relationship. The necessary condition. And then there's also the word sufficient. A fresh horse is sufficient for the knight to win. A fresh horse is sufficient for the knight to win. All you need is a fresh horse, and it will suffice that you win. All you need is a fresh horse, and then it suffices that the knight will win. It suffices for the knight to win. All right, so which one contradicts that? This or this? Here, you got a fresh horse and the knight lost. Here, the knight won with a tired horse. Which one contradicts this? That a fresh horse suffices for the knight to win. Give that knight a fresh horse, he's going to win.
K not an H.
Right. He got a fresh horse, but he lost. So this is H implies K. So the sufficient condition, right? So when you say H is necessary, it puts H in the conclusion. When you say H is sufficient, it puts H in the hypothesis. So when H is necessary, it's the larger set in the containment. When it's sufficient, it's the smaller. And then if you say necessary and sufficient, so a fresh horse is necessary and sufficient for the knight to win. All right, then it's double implication. Oops. So those are the ways in which implication is used in English. There's, H if K, H only if K, H is necessary for K, H is sufficient for K. So all of those are implications, but where H is first in the sentence and K is second in the sentence, but the implication can get flipped around. How do you determine? Until you really get used to that, the only way you tell is just by comparing the two and seeing which one is wrong. Okay? So is there a quicker way to do it? No. You just really have to think about what does the English really mean and which containment relation is it describing. All right. So things other than implication, let's say either. The horse is fresh and the armor is strong. Or the knight will lose. Either the horse is fresh and the armor is strong, or the knight will lose. Yeah, I have armor strong. Okay. So we have either or, and then we've got this conjunction. So I'm mixing up conjunction and disjunction in the sentence. Which one comes first? Which one comes second? Which is the outer sort of connector in this sentence? Is it the or the and? Right? So we have H and A or K. So H and A or K. But you can't write that, right? That's ambiguous. Oops. That's it. Horse and or. There we go. You can't write that. It's ambiguous. You need to either have the parentheses on the H and A or on the A or K. Where does it go?
Around the H.
H and A.
Right, yeah. The either or, yeah, the word either really tips it off, right? This statement is a disjunction. Within that disjunction, you have a conjunction here, right? But the statement is either, P or Q, right? P itself was a conjunction, but that's fine. P was a conjunction in Q. Either P or Q is P or Q. P just happens to be H and A. Or if you had something like this, H, I guess we need another proposition for what I'm about to do. Horse is fresh, knight will win, armor is strong. O is the opponent cheated. I guess I should say the opponent. Let's see. The knight lost. The armor was strong. And the horse was fresh, or the opponent cheated. The knight lost, comma, the armor was strong, comma, and the horse was fresh, or the opponent cheated. This is a nice grammatical example as well of what's often known as the Oxford comma. Right, I mean, when you have a list of things that you want to make a conjunction, you put them delimited by commas, and then you put an and on the last one, right? The month is January, the day is the 20th. The month is January, the date is the 20th, the day is Wednesday, and it's cloudy outside, right? So when you do that, you don't put and each time, right? The month is January, and the date is the 20th, and the day is Wednesday, and it's cloudy outside, right? You skip the first few ands, you just put in the last one, right? But they often say, well, don't put that last comma. Don't put that last comma. You can put that last comma. I know they usually say don't, but you can. In this case, you have to. There are instances in which you have to, and in particular when you're mixing your ands and your ors. Right, so which one is this? Because I have a comma before the and, it means it's a conjunction. So the knight lost, it's K naught. And the armor is strong, it's A. And the horse was fresh, or the opponent cheated. So the last thing in conjunction is the disjunction, like that. If I left out the comma, you can't tell actually. This might be, if you leave out the comma, it could be like the knight lost, the armor is strong, and the horse was fresh. Oops. Or the opponent cheated. Right? But having that comma there says otherwise, right? Because you don't know. If you skip that last comma, this is either, a disjunction of three things or a conjunction of three things. You can't tell. You need that comma there. So it's this.
Just to clarify, in example H, isn't it supposed to be K naught?
The knight lost, armor was strong, and the horse was fresh, or the opponent cheated. In this one here? Oh, yeah.
Yeah.
This is K naught. Yeah, you're right. Sorry. Okay, so that's I, and then for J, let's put the other one where we'll put the comma in the second place. So if the comma is here, then it becomes K naught, or armor was strong and horse was fresh, or opponent cheated. So it's knight lost, or armor and horse, or opponent cheated. So just depending on where the comma is. So that final comma in a conjunction of three or more things, or a disjunction of three or more things, is called the Oxford comma. And sometimes you actually do need it. I believe this is the operative example where it does. Normally you don't need it. I always put it in. That's my feeling. That it's nicer with it there.
So what would be an example of when you had K naught and H and A in parentheses and then had or O? Like in English, what would be
I
an
think
example of that?
if you put the conjunction over here, I think you'd have to move things around. K and H. Yeah, you would have to have the connector here. So in both sentences, right, the knight lost, comma, the knight lost, comma. So what the connector is here depends on what the final connector is, right? I mean, like when you write the sentence, so the month is January, the date is the 20th, the day is Wednesday, and it's cloudy outside. This is a conjunction.
I was going to say it's inauguration day.
I'm sorry.
Nothing, never mind.
Oh, okay. So what the connector is here, here, and here is given by what you write there. If I change it to, so this is the month is January, and the day is the 20th, and the day is Wednesday, and it's cloudy. Right? If I put an or here, the month is January, or the day is the 20th, or the day is Wednesday, or it's cloudy outside. Right? So here things got confused because we didn't have that final comma, that Oxford comma. But when you're not using conjunctions within disjunctions and things like that, you can just leave that one out. Right? That's in journalistic style, that's insisted upon. You don't use the Oxford comma. And you write things so that there never is a confusion about it. Anyway, I mean, it's just niceties of grammar. I always put it in. I like it. That's me. All right. So that's translations. We'll do some more examples next time. Get started on the ones on the homework, please, today. So this one's nice, bears and fish and snow. So nice winter theme. Let's talk about negations. So negating English language statements. So I don't know if any of you are old enough to remember, but like around 20 years ago, people used to, say this thing. It was sort of a, popular mode of speech. Like you would say something that was wrong, and then at the end you would just say not, right? Oh, I really like that shirt you're wearing. Not, right? To lead somebody on. I don't know if any of you remember that. Anyway, so if you would like to negate a statement, other than doing it that way, by writing it in clearer English, how do you do that? Okay, so the most surefire way of doing it is to use propositional logic. So, for example, so write the negation of the statement. If the restaurant is good, then the prices are high. So if the restaurant is good, then the prices are high. So we want to negate that. Well, the first thing you want to do is translate this into propositional logic. Right? So if the restaurant is good, then the prices are high. So that's propositional logic. And now you want to negate it. So you do the 2001 speech pattern. G implies H, not, right? Now what you want to do is you want to take that negation and distribute it through. You don't want a negation over a parentheses ever. Okay, you want that negation just over bare propositions. So now what we do is we apply tautologies to to distribute this through. So we have the implication tautology. So we did this one already, right? So this was G not or H not. And then there was De Morgan plus double negation. And this becomes G and H naught. Right, so now you translate back into English. So if the restaurant is good, then the prices are high. The negation of that is the restaurant is good, and the prices are reasonable. Or whatever other ways you can use conjunction. So the restaurant is good and the prices are reasonable. But since it's a negation of an if-then statement, rhetorically people might say, like, the restaurant is good, however, the prices are reasonable, or but the prices are reasonable. Right? Or something like this, the restaurant is good, however. Right. So you can use either any of these words for conjunction here. So the restaurant is good, but the prices are reasonable. The restaurant is good, however the prices are reasonable. The restaurant is good and the prices are reasonable. But it's all just G and H now. Okay, so what about something like this? So write the negation. So if the food, oh, I'm sorry guys, it's 1:18. If I go over time like that, please remind me.